going to teach you how to sketch a quadratic function. This is a general form for quadratic. Okay, or quadratic function. Okay, given that for quadratic, we have to check A. A is supposed not equal to 0. When A is equal to 0, shows that this is cannot say this is quadratic. Okay, therefore B. And then it depends on A. When A positive, the graph is smiling graph, concave up or opens up. Okay, the graph is open up like this. Let's say this y plus x squared. The graph is smiling graph, opens up. When A is negative, the graph is opens down or sad graph. This is example for y plus negative x squared. This is actually the general form, the general pattern for quadratic. Okay. For opens up, the graph has a minimum point. This is middle point, minimum point. For this graph, okay, this graph, the set graph, it has maximum value in the middle. Here is maximum value. Let's say given a function, quadratic function, first thing, before sketch graph, it is better for you to completeness square and get the value like this completeness square. From this completeness square, it's easy for you to sketch the graph. Okay, here is when x minus 1 is equal to 0, the value, the extreme value, whether there is maximum or minimum, it depends on the pattern of the graph. Okay, this is 1. And y, this is y value, the value for y, the graph. So at this point 1 1, the graph is at the maximum or minimum. It depends on A. When 2 greater than 0, the graph is smiling graph. So this graph has a minimum point. Okay, so let's sketch the graph. Okay, 1 1 1 1, that is the minimum point. Okay, and you know that it is smiling graph. Just sketch this curve, and this is the graph. Settle. And to find the domain for quadratic always real numbers. Why? Because of the x value, we use x value from negative infinity up to infinity. But for range, okay, it depends on the type of the graph. Okay, when the graph, that is the smiling graph, it has the minimum, starting minimum up to infinity. When the graph is set graph, okay, maybe from the bottom negative infinity up to the certain maximum value. Okay, for this one, as you can see, okay, no graph below here, no graph below x axis until up here. This is the first value, starting 1 up to infinity. This is domain. This is range for this graph. Okay, this is start from 1 to infinity. Okay, so range is 1 to infinity. Settle for the graph. Okay, proceed to this type of the graph. Let's say you want to sketch the graph, the same graph, but in the restricted domain. Domain is given. Okay, first thing is write the domain, number line, use number line. Okay, so this is domain from 1 to infinity. So the graph is on the right hand side, in this side only. No graph on the left hand side. Why? Because I'm no domain here. So sketch the xy axis, dotted line. So you need to sketch the graph y equals to x minus 1 squared plus 1 quadratic within this domain. Okay, so for the old graph, okay, you can see the pattern of the graph for quadratic is smiling graph. So now domain is given. You cannot sketch all here like this smiling graph because it depends on the domain. Let's say this is 1. 1. Just substitute. When x is equal to 1, 1 minus 1 0, 0 plus 1. So this is, the first point is 1. 1. Okay, and try to check. Take one point. Let's say 2. 2 minus 1, 1. 2 plus 1, 3. So you know the graph is increased. Okay, slope and increasing. So maybe the graph is half this whole graph. Just sketch. This is the okay, this confirm. This is the graph for the given domain. So now, okay, domain given from 1 to infinity. Now how to find a range? Range is also starting, okay, no, here, starting here. No graph below here, okay, and then from 1 up to infinity. That is range. Range from also from 1 to infinity. So this is how to sketch quadratic within the restricted domain. Okay, now with the same function, but the domain is restricted from x lies between -1 included to 2 to exclude. So first we write the number line to show the domain. The domain is from here to here. From -1 included up to 2 exclude. Means you need to sketch the graph quadratic within this domain. You know this is quadratic. Maybe since this is more than positive, it's positive. The graph is smiling graph, and it has the minimum value when x is equal to 1, y 1. Okay, but now within this domain, you can sketch the whole graph. Depends on the given domain. No graph on the left hand side and also on the right hand side. Okay, but the overall graph is like this. Okay, just substitute the value when x is equal to -1. Substitute here -1 minus 1 4 8 plus 1. So y is equal to 9. -1. Let's say this is 9. Then circle. So this is 10. Circle. And then next step, okay, you know this is 1. 1 is the minimum value. 1. Let's say this is 1. The minimum value. And x is equal to 2. Substitute 2 minus 1. 1. 2 plus 1. 3. Y is equal to 3. So the coordinate is 2, 3. Let's say this is 3. 2, 3. And this is empty circle. And you know this is the graph is okay, like this. From okay, opens up. Okay, from here you can sketch here and up to here. So the graph is something like this. Okay, opens up. Okay, just check when s is equal to 0. Substitute 0 to 1 times 2 plus 1 also 3. Something like this. Okay, this is the perfect graph for the given domain. Now we're going to find the domain given from 1 to 2. We're going to find range of f. Okay, range check y value. Okay, range check y value, and from here below here no graph starting 1 included, 1 for y included. Okay, here even though here exclude for on the right hand side, but the 3 here include, so consider taken up to 9. The last is include, so the range is starting from 1 to 9 include. This is range for this given domain. Okay, that's all for quadratic function.